Okay, let me explain. Right, here's an example. So you've got two people that I need to choose from a test batch. You've got three people, let's say Alison, Ben and Clara. What we're going to do is list out as many two people combinations as possible. Okay, so let's call Alison A, Ben B for Ben, and C for Clara. Alright, so just an example as a pair that we can combine. We've got A and B, Alison and Ben. Think of all other combinations that you can think of.
Ben and Clara.
Ben and Clara, yeah, B, C.
Alison and Clara.
Alison and Clara. Just a clue, there's three more.
Oh, there's three more.
Keep thinking. How about this one? We can rewrite.
B and A?
Yeah, B and A. What else is there?
C and B.
C and B, yeah.
And C and A.
Sorry?
C and A.
That's right. Can you think of anything else? There are none. That's actually all of it. See, yeah, that's actually all the combinations you can get.
Right.
Yeah, see how it takes a long time to actually get all those possible outcomes? So the easiest way is actually using a tree diagram, and I'll teach you how. So for our first pick, what option? How many people do we have to choose from? Alison, Ben and Clara, right? So what I'm going to do is I'm going to draw three branches, okay? So because we can choose Alison, Ben or Clara, right? Let's say on our first pick, let's say our first pick was Alison, then which people do we have to choose from? If I chose Alison, what do we have left?
Ben and Clara.
Ben and Clara, yeah? So I have the option of choosing Ben or Clara. Does that make sense?
Yeah.
Let's say instead of my first pick was Alison, let's say my first pick was Ben instead. So if I chose Ben, who do we have left?
Alison and Clara.
That's right. So I have Alison A, Clara, yeah. Same thing with this one. Let's say my first pick was Clara, then who do I have available for my second pick?
Ben and Alison. Alison and Ben.
Alison and Ben. That's right. Okay? So if I do this out, if I write the outcomes now, this is how you write the possible outcomes. So A and B. Yeah?
A and C.
A and C. That's right. Now for the next branch.
B and A.
B and A.
And B and C.
B and C.
And then C and A.
A.
And then C and B.
See, that's pretty much all the outcomes that we listed in the beginning, but that takes a lot of time and thinking. Whereas this one, we didn't have to think at all. It just automatically gives us all the lists that we can get. Okay? So that's the purpose of using a tree diagram. So what we're going to do now, knowing that, is we're going to actually apply an actual question. So looking at the next question, if two coins are tossed, okay, so two coins, use a tree diagram to list all the possible outcomes. Okay, when we toss a coin, what can we get?
Heads and tails.
Heads and tail. Okay, so for our first branch, we can get head or tail. Okay, let's say we got head in my first toss. On my second toss, what can we get again?
Heads or tails.
Head and tail, heads or tails again. Yeah? Same thing here. If my first toss was tails, for the second toss, I can get heads or tails again. So those are all my possible outcomes. If I write them out now, my first possible ways, heads, heads. Yep. Same thing as the previous one. What's that?
Tails.
That's right.
And then tails and heads, and then tails and tails.
That's right. So these are all the possible outcomes that I can get if I toss two coins. Okay? So the questions from here now is find the probability of tossing two heads. This is two heads. Yep. One out of 1, 2, 3, 4. That's right. Okay, so that's basically the purpose of using a tree diagram, listing out all the possible outcomes possible so you can calculate the probability from that. Same thing, a head and a tail in any order. How many head and tails are there here in any order?
Two.
This one, head and tail, or tail and head, because it doesn't matter which order it is. So how many is there? 2 out of? Yeah, which is the same thing as?
1 and 1.
Half. Yep. Head first. So how many of these start with H?
2.
1, 2. That's right. So once again, that's 2 out of 4. That's a half. Yep. Only tails?
2.
Only tails.
Oh.
Only tails. There's only one. Yeah? Because this one has a head, this one has a head, that has no tails. So only tails that's the only outcome possible. Yeah, 1 out of 4. Does that make sense? Okay. Now, this is an extra question here. If the coins are tossed 200 times, what is the expected number of tossing two tails? So the easiest way to do that is basically the probability of tossing two tails is 1 out of 4, yeah? What you need to do is just basically get that number and times it by 200.
Oh.
Okay, that will actually calculate the number. 200 divided by 4, yeah, that's right, 50 times. Okay, very good. Okay, so that's actually how you calculate the expected number of times if you tossed it many, many times. You just times that number by the probability. Okay? It's expected number. It's not the actual number, obviously, in real life. That's the expectation. Yeah? And that's where probability is used in tree diagram. Make sense?
Yeah. This in year 4.
Okay, so you know yesterday how we used tree diagram to list out all the possible outcomes? Now, if you want to list out all the possible outcomes specifically for anything with dice involved, it's actually better to use table of outcomes. It just takes up too much space with tree diagram. So if you've got 2 dice rolled, so you've got the first die here, and you've got the second die here. So basically, if you want to list out all the outcomes, it's like basically times table. You're just writing the numbers together like this. So 1, 1, and then this could be, let's start with 1 here. Then this is 1, 2, then this would be 1, 3.
1, 4.
Yeah, that's all we're doing.
5. 1, 6.
Yeah. In the video, I'll fast forward this, but then this would be 2, 1.
2, 2.
Yeah.
2, 3.
And I'm just going to keep going.
2, 5.
So once we've listed everything out, these are all the possible numbers we can get if we roll 2 dice. Okay. How many possible outcomes are there? So how many different combinations are there here? So looking at just all 36, that's right. And how did you get that quickly?
6 times 6.
Yeah, that's right. So there are 36 combinations here. So that's 36. And the reason why we need that number is if we wanted to calculate the probability, it's going to be out of 36. So the probability of rolling doubles, how many doubles are there? We got 1, 1, 2, 2. These are doubles, yeah?
Oh, 6.
Yeah, that's right. There are 6 of them. Doubles means the same number. So there are 6 out of 36, and that's 1 out of 6, yeah? 2 even numbers? I actually don't know, so let's count 2 even numbers. So none of them here, because they all start with 1. That's an odd number. 2 even numbers, so this one, yeah, 2, 2, 2, 4,
And 2, 6.
2, 6. We have to keep going. Obviously not here, because it starts with 3.
4, 2.
4, 2, 4, 4, 4, 6,
And then 6,
6, 2, 6, 4.
and 6.
Oh my god, I wrote 6, 2 here. I made a mistake. 6, 6. Right, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, so 9 out of 36. Obviously that can be simplified, which is 1/4. Very good. Or 25%. Okay. Let's do the next one in black. Rolling 2 numbers greater than 5. So that means we've got to look for combinations for here. If you add them, it's more than 5. So for example, this is my first one because 2 plus 4, that's 6. Yeah, so I'll just write it here. That's 6. How about this one? Is it greater than 5? Yeah, because 2 plus 5 is 7. So I'll just write 7 here, and this one is obviously it as well. So anything more than 5. So how about this one?
Yeah,
Yep. That's 6, 7, 8, 9. Can you see the pattern? Oh, how about from here?
1 and 5.
1 and 5 from here, yeah?
And 1 and 6.
Yeah, so can you see the pattern? 2, 3, 4, 5. I'll just circle in black. And then all of this is greater than 5, obviously.
The whole 6.
And the whole thing. All right, so I've got, okay, let's write them out. So I've got 2 here, 3, 4, 5, 6.
And 6.
So we got to add them up because that's all the possible outcomes. So that's 5, 9, 14, 20, 26. Okay, so the answer is 26 out of 36. I can't simplify that in my head. What is it? Well, actually, let's do it. Divide by 2. That's 13 out of
18.
18. Yeah? You can't simplify that, obviously. Yeah, so that's basically how you list all the outcomes for dice. Okay? So even here, I know it says a coin. It says a coin is tossed and a die is rolled. When you see the word die or dice, it's best to use a table instead of a tree diagram. And I can explain why, but table is best used. So what do you think goes in here? Looking at the spaces of...
Oh, 1, 2, 3, 4.
That's right. So I'm going to put all my dice numbers here.
Oh, and then the coin will be heads and tails.
That's right. This is where you put the outcomes for coin. Okay? And it's the same thing. You just fill it up. So this is going to be, let's start with this one. Head and the number 1. Head and the number 2. And so on. Okay?
Right, so here, T1, T2.
Yeah, okay? All right, so first question What is the probability of getting a tail and a 3? So we're looking for T3. Does that make sense?
Yeah.
That's the early one.
2 out of 12? No.
It's only one. Yeah, 1 out of all of these outcomes. There are 12 of them. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 1 out of 12. Okay? Now, this is a tricky question. What's the probability of getting a head or an even number? If it says or, you have to add or count all the outcomes with head or even. So everything with head and even, count them up. So, how many heads are there?
There are 6.
6. That's all of these are heads. Okay? Now from here, how many even numbers are there after the heads? After the heads. Looking at the tails, how many even numbers are there?
6.
Oh, just after the head. Yeah. So there's one even number here, second even number here, third even number here, right?
Yeah.
So the number of outcomes which has a head or even number is 1, 2, 3, 4, 5, 6, because that's all the heads. And 7, 8, 9. Does that make sense?
9 out of 12.
Yeah, the reason why we didn't count the even numbers here is because we counted all of them. These are all the heads, which includes the even numbers. So we don't count that again. You don't count it twice. When we count all the heads, it's already included. We just had to then count on the extra even numbers after that.
Yeah.
Yep, so that's why it's 9 out of 12, which is
3 out of 4.
4. Yeah? Okay, that's fine. Okay, so basically when you get a die question, instead of using a tree diagram, use a table. And here's the reason why. Let's try and list this out using tree diagram. Okay? So, if you roll a die, how many numbers are possible? 6. So that means you have to start with 6 branches. Okay, this looks fine so far, yeah? This is my first die. Now, on my second die, if I roll it, what numbers could I get again?
1 to 6.
1 to 6 again. Yeah, another 6 numbers, because both of the dice have the same numbers. Can you see the issue if I keep going with this? I need to write this again here, and then here, and then here. It just gets really messy. And then you can, but you just need a ridiculously big paper to do it on. It's just a lot more organized and neater if you just fill up the table, as you can see. And then it'll be a lot harder as well if you're trying to spot out the combinations that the question wanted. Yeah, does that make sense? Yes, so when it says anything with a dice, use a table of values. Okay?